This is a demo video to show how to determine the shadow on the window and calculate its area. I have a Revit model of a multi-story for shaded area calculation. On each side of the building, there are various types of shading device like horizontal, vertical, accurate, or complex and organic shading device elements. Performing the calculation for model at this scale need an advanced tool, and so I'm using Revit API to develop an add-in to slow it. And I'm using Microsoft Visual Studio, an integrated development environment for better programming. As you can see on the screen, there are lots of classes and functions in this add-in, but I want to highlight some main settings here. This function for getting data of windows and shading device from the Revit model. Then I define some type variables in calculation. Those are vernal equinox, summer solstice, and winter solstice, because these are days of year with average and extreme sun location. Choosing this day for calculation help give better data of calculated shaded areas for limit value. And times in each day are set at 9 a.m., 12 p.m., 3 p.m. for simple tracking of calculated value. Extrusion Analyzer class of Revit API is the main core of this add-in to project the shading device onto the window along the given sun direction. Then, using the Revit API of the direct shaft class, we will create the shadow as a real element with the category input is mask. And the new shadow element will have parameter with value of calculated shaded area. This add-in is built as a DLL file. DLL file is the dynamic link library that contains executable code and resource, and that can import it to Revit as an add-in. First, we will have a test of add-in we just created on a typical single floor of a building for quick result. The model you are seeing here is comprised of various types of shading device on four sides of the level. These are windows on four sides directly face the sun on its path. Before running the script, let's click on any window to see there are no value on this parameter. This is to get the shaded area data, and on the value are not available. We will get back to this after debugging the add-in to see the difference. To load the add-in, I use a tool called Add-in Manager. You can find it in AutoCAD website or web forum and install it in add-in tabs. This solution allows us to load, reload, and run the add-in without close the Revit or restarting Revit. Simply click on the Add Imager, navigate to the folder with your DLL file, and then click Run. The processing time varies by complexity and size of the model. In this example, it takes less than 1 minute to finish the typical floor, and for the entire building, just around 20 minutes to see the result. Finish. We are ready to check our result. You can see in the model is appear lots of Revit direct shadow element. It represent the shadow of the uh, shading device on the window at specific time. And remember the window we chose earlier. Now we can click on it again, and you can see it parameter had three value because we have set the calculation for 3 times a day on 3 days in a year, and so there are total 9 value of shaded area in this window. You some not applicable value. This is because there is no sunlight or touch window at specific time or day of year, because sometimes in the morning the window of the sun is the same direction with the window, but in afternoon the sun move to the opposite side of the building, so there are no sunlight in the afternoon. Yeah, and you can see its value here. It represent the shaded area at 9 a.m., 12 p.m. and 3 p.m. And we can click on the shadow element, and this is the shadow we needed. And now we can see the variable reported in the property, which are the element of the window. This is the day, and this is the time, as well as the area of the shade. Yeah, and we can check for another shade in a different time, daytime, and different area. Okay, in this step, I will set the sun path on this building on this day, 21st of June, at 3 p.m. To see if the value from the add-in and the shadow we are seeing are matching. Okay, the time and the day will is set to 21st of June and at 3 p.m. Okay, I turn on the shadow here, and now we can see that Revit direct shape represent the shadow on the window, and it correct with the shadow in the Revit environment. Yeah, and we can check for another window, maybe this window, because it had two shaded device. One is vertical fins and one is the complex or the organic shading device. You can see it has the complex geometry, and this is the shadow uh, on 21st of June at 3 p.m. and the shade of this shadow shading device had the same position on the surface of the window. Yeah, it's correct. And the same procedure for checking is apply for other element. You can check what whichever element here and check the shadow is correct or not. And after checking, the add-in I created is applicable and reliable. After that, we can create an add-in tab has tools like this. Create the edit tab called TTV, and we had some tool like this. Yeah, to calculate the shadow error to show the shadow on the window. Okay, and for the whole building, I already run the add-in on the entire building with the same procedure, and I made some custom to the time frame for calculation. It is set from 7 a.m. to 5 p.m. It means I will get the shadow area 10 hours per day. And the result you can see is I show on the shadow here, and each window we have a lot of shadow element. Yeah, it's quite nice. And when you click on the window, you can see we had the different value because maybe in this morning this side don't have the sunlight, but in the afternoon you can see we had the shaded area in the parameter. Yeah, okay, you can see it's quite nice. Yeah, very beautiful. Yeah, in the opposite side we can see we have the shadow in the morning, but afternoon there are no sunlight. And this will have uh, observe different shades during daytime and extract the maximum, minimum, and average value of shaded error accordingly. And next step, the calculated error can be scheduled and reported, and this will add the design process in the layer stage for sustainable design.